Hello, students. Jumping into the last module of this, which chapter 12, which is module H. This is the online one, and we're going to be using GeoGebra. And again, if you want to, you can kind of read through and say, um, how did GeoGebra come about? This was a long time ago, so more than 20 years ago it came out, and it has since launched online in a free resource. So we are going to be using um, yeah, the toolbar. And let's see here. I gotta look. I have a feeling this one is created a long time ago. And so they're defining the terms click. All right, good to know. GeoGebra has been updated a few times since this obviously has been done, but we're going to be doing things like constructing a triangle. And so 3 different activities will help you learn and practice various tools. Construct an inscribed triangle. And you will construct a triangle in a circle, having one of its sides as the diameter of the circle. Open GeoGebra. We need the graphics view. They say hide axes and algebra view, but when you are going to GeoGebra, and I'm going to go back to the main page in GeoGebra, just so you can kind of see how I get here. This is the homepage, geogebra.org. Then under calculators, you no longer have to go into the one that has all the axes. You can go to one that's called geometry, and the grid lines are not there. There is a settings feature on the side that allows you to show the grid, but I would recommend that you leave those off. The default is to not have them on when you're doing geometry pieces. Now, again, you could have them up there if you want to plot specific points or do geometry in a very precise way. You could, but not critical. Okay. First, construct 2 points A, B to be endpoints of the diameter of the circle. To do this, click the New Point tool, then click on 2 different locations on the graphics view. Let's take a look at what that looks like. When you go to GeoGebra, there is right up here, your main tools are going to be located right up in this area. The shortcut or advanced tools will be under the More button. So let's just kind of go through these pieces first. The tools, you have a move tool, a point tool, a segment tool, line, polygon, and a circle with a center. Okay, all of these are the basic tools. If you want to create points, you simply click point. Now you have to be able to kind of see this part. So I'm going to try to kind of really show. Right now, the piece that says point is bold and kind of a slightly different color. Watch what happens when I click on segment. Okay, now the segment word is bold and a little bit different color. If I want to click on point, I have to make sure I'm selecting it. If there is frustration from students, it's that they want to do something, but the wrong tool is highlighted. So if I wanted to build a segment and I went out here and clicked, you're like, oh, it just built points. That's because the point tool is highlighted, okay? And just remember, you can't like click and drag anything while you are selecting the point tool. Every time you try to click and drag something, right? Oh, looks like it can't. Oh, they did update that finally. Yes. You can click on drag something, but if you miss it by just a little bit, you create a new point because you're on the point tool. If you want to move something, click on the move tool, and that will make it so you can move things. And if you accidentally click, you're not creating a new point. Okay. Phew. Underneath the More option, you have things that you can select, things that you can delete. If you want to delete objects, you simply click on them and they will be deleted. That object no longer exists in the system. Okay. All right. If you want to hide them, click on the Show Hide Object. You'll notice it gets blue and it'll hide. I can hide a point. And then if I click back on the move, it disappears. But if you click on the Show Hide, it's there. And so you could click it to bring it back. It's not like it stops existing. They just don't show it to you. Click AB. To display the names of the points, click the Move tool, right-click above each point, click the Show Label from the menu. See, this is this is an older one. So I'm glad I'm doing this, going through this. You don't have to do that. The default is that it will label them. If you don't want them labeled, you can choose to not label them. So right here, when I click on a point under this, I can choose to duplicate it, fix the object, show a trace, or look at settings. And under settings, I can change the name, the color, the style. I can do some advanced things with layers and graphics, which we rarely will do. I could use coordinate systems. And anyway, those are the biggest things. Okay. Now, here's a fun one. There is an option called Show Trace, so that when I drag something around the screen, I can see where it moves. This allows you to, as you drag something, occasionally other things are tied to it, and kind of see what happens. So, for example, actually, I'll probably do that one as it as it comes in. I'm going to unclick the Show Trace, and let's just delete all of that. So I'm going to get rid of that piece here, and I am going to select objects, and I'm just going to grab a bunch of these objects and delete them. Select object to be deleted. Oh, where's my clear? Maybe I have to snap to grid, clear all traces. There it is. Okay. Now, if you want, you can create an account here, and this is what I recommend everyone do. Create an account, so that way you can actually save items. You can say, hey, here's question 1, and you can save it. So let me go ahead and jump in and do that. I know I was goofing around first. If you don't, there's nothing wrong with it. You can probably go through and do all of the questions that you need to do, and you can click and drag and move and do everything you need, but it just won't save it if you want to reference it later. If you are using just the web version, you can always go back up to the refresh. It'll say, hey, it's not going to save your changes. Just click reload, and it'll boom, here you are back at the blank screen. All right. So it says sign in. And let's see here. What does it show? Oh, it doesn't show you that. Let me share my whole screen then. There we go. That's me. Okay, forget about that. Where's my... I am screen sharing? No, I'm not. I'm looking at myself. Dork. Okay, let me minimize that. Oh, okay, there we go. Okay, so here's the little pop-up window that comes up. Okay, so let's see here. Do I have one with S. Wallstrom at Miracosta? Oh, that's my email. I don't know. Uh, oh, what would I have used? That maybe? Nope. Okay, let me try. Let me see if I've got this account still. And it says check my inbox. All right, let me pause this real quick and check my inbox. All right, we're back. Let's try this one more time. Okay, let's go up here to sign in. Oh, did it bring a pop-up? There's a pop-up. Okay. Pop-up, here we go. Let's go Wallstrom. And just put in the password. Thank you. Still would like to sign in. Okay. So you can do this to create your account. Give it, your, here we go. There we go. I'm using GeoGebra as a teacher. You can put student. Gender, don't have to. Year of birth, make up a number. Location, website. What is this? No, I'm not putting my website on there. I don't even know what that is. Okay, and then tell the community some things about you. No, I'm not going to do that. And that's fine. That's fine. That's fine. Okay, so everything is now set up, and I'll click save. And my account information was successfully set up. So now, if I close this and reload it, I should be signed in. I did sign in. You stinking. There we are. Now I'm signed into the main screen. I don't know what I was signing into a moment ago. Maybe someone has my password now. But once you're signed in, it'll actually give you a little symbol up here that doesn't have the sign in anymore. And now I am ready to build. So what we're going to do is go through a few of these together and then just kind of showing that you can save these as you go. Let's take a look again. Draw two shapes, A and B, label them, construct AB, which is the diameter, create the center by using the midpoint or center tool, and then click the move point. You can see that it moves around, construct the circle, and then construct point D on the circle. Okay, so that's what we're going to do. Those are the pieces we're going to do. So step one, create the point. Point A, point B. Then build the segment between them. So notice I'm clicking on the segment tool, and I click and I drag. As a note, and I should bring this up because I think it's really helpful, you could create a segment by itself and it would label the endpoints for you. So that is a shorter way of doing a segment if you need one. All right, now I need to go the more, and I need to find the midpoint of this segment, and under construct, these are the constructions that we would use. Construct the midpoint. I click on it, and I click right here. Now it automatically gives me the name C for the midpoint. Again, if I don't like that, I can change it, but for now, I'm okay with it. Right? Next, we're going to create a circle that has AB as a diameter, which means that C is the center. So choose the circle with the center tool, click on the center, and then drag to the outside. And this is where it gets fun. Make sure that see how my cursor is up here? It may look like it's on. See that? It may look like it's going through A and B, but as soon as I move A and B, the circle really isn't. The only thing that's changing is that center point, but it doesn't go through A and B. So I want to undo those. I'm pressing Control Z to undo those. Circle with a center, click on the center, go out to the edge and click on one of the points. It could be A, could be B, doesn't matter. And then click on the point tool and pick a point somewhere on the outside edge. Okay, let's go back. Construct point D, click on this and move around. Now use the segment between 2 points to construct AD and BD. What observations can be made about this triangle? Okay, grab my segment tool, AD, and click the segment BD. Okay, so I built a circle. I picked a point on that circle and I connected it. What do you notice about this triangle? What observations can you make? Now, this is sometimes where it's helpful to come down here and say, well, wait a minute, why don't I measure an angle? Maybe that will help me see something. To measure an angle down here in the bottom, it always gives you the tip. What are you doing? This one says select 3 points or 2 lines. So if you pick 2 lines, it will measure the angle. And if you take a look at what just happened, and I'll zoom in a little bit, it's 90 degrees. What if I click on point B and I move this circle around? What do you notice? 90 degrees. What if I grab that point and I pull it around to this side? 90 degrees, right? So it looks like no matter where I pulled this point, I get 90 degrees. It might say something about the type of shape that we have created, and it might tie into some homework questions that you've had before, where in the homework they connected this to this, gave you 2 isosceles triangles, and said, hey, tell me something about these isosceles triangles, and can you prove that that angle is 90 degrees? Hint, hint, nudge, nudge, wink, wink. All right, save this construction in a file called inscribed triangle. Got it. So it says save it. So I go up here and let's see here. I can save online. Okay, I'm going to save it. We're going to call it inscribed circle. That's an inscribed triangle in a circle. Okay. Now you can see where is it? It's either private or shared. I'll leave it as shared for now and I'll click save. That shared allows me, if I want to click on the share icon near the top right up here. And I can share this with someone else, either as an embedded. I can copy the link and send it to my friend who's in the class and say, what do you think? What did I do wrong? I can even export the image or print if I want. Oh, shoot. Yep, this is going to happen to you too. I just clicked to get rid of that other screen, but I clicked on the white space and my tool was highlighted as segment. And so it's starting a segment for me. I'm going to go ahead and press the escape button, ESC, and that will stop whatever it was doing so that I don't accidentally create more of those. All right, there we go. Now we need to construct an isosceles triangle. Okay. We can construct an isosceles triangle in different ways. We can use two radii of a circle as the sides of an isosceles triangle. We're going to construct triangle OPQ. And what are we going to do? Open a new window. And we construct a circle with center A and goes through P. And then we're going to practice renaming. Okay, so they want it to be OPQ, and we're going to rename. And then construct another point on the circle and then create the segment, and you will see that we now have a beautiful isosceles triangle. And what seems to be constant about the triangles as we move the points? Well, let's jump over here and try it. So what we're going to do is we're going to create a new drawing. So I'm going to click refresh. Refresh keeps me signed in. And oh, I want to close that one. Hold on. Okay. I guess I can say clear all. All right. Let's try that. I've tried clear all. Let's see if it works. And yeah, there's not any other new settings in the new version, so that's okay. All right, here we go. So what I'm going to do is I'm going to build myself a segment. This time I'm clicking the segment tool and I'm clicking 2 points, AB. Then I build a circle with that center. And then I pick any other point on the circle and connect segments as seen. And boom, boom, and boom. Now I'm still highlighted on the segment tool, but I don't want to be. So I'm going to click on the more. And this is show hide label. Let me click on the more and go to A. And then notice the 3 dots down here. I can go to the settings. So I don't want this to be A. I want this to be O because that's what they said. Okay. And so then I can leave this open or I can close it. I just changed the name of that one to O. When I click on my new point, I could just come over here and say Q. And when I click away from it, notice it updates the label to Q. And I'm going to drag this label over so I can see it a little bit more. And I'm going to click on that point. And here's P. And I click away and there it is, OPQ. And it says, there we go, OPQ. Rename, rename, rename. We did. Construct a point on the circle. We did that. Drag, and we're good. What do I observe? What do I observe? What seems to be constant about the triangle as we move the points? Okay, well, let's see here. As I move the points. Okay, it's an isosceles triangle. Here it's acute. Here it's right. There it's there it's obtuse. And again, it might be hard for me to see these. I'm going to click on the measure angle option and click 2 sides. And I'll do the same down here. And what I think they're trying to get you to see, which I think is a little challenging without having those measurements show up, is if you drag the points around, take a look at these base angles. And honestly, that show hide object, I'm going to click on the circle because that circle just kind of gets in my way. Ooh, I need that point back. I accidentally hid one of the points. Okay, there we go. All right, so there we go. Now I can use this and kind of move these around. You'll notice, though, you cannot just drag this shape anywhere in the screen. It is kind of locked to this center point O. Remember how we built it? We built it as a circle. Okay, but take a look. This angle, Q, and this angle, P. What is happening? Does look like we get some really cool things happening with those. Very cool. All right, let's see here. What does it tell us to do next? Using the distance and angle tools, we have our own name, use the move tool, measure OPQ, measure object properties. Got it. Using the angle tool, measure the other two interior angles. Got it. Okay, there we are. Oh, and it doesn't measure the other angle, so I guess, oops, get rid of that. I could measure using the measure tool down here. I could measure the angle at the top. I'm going to choose 3 points this time. I'm going to go Q, O, P, and you can see it still builds it for me, if that makes sense. And then I can kind of use the move tool to move that out of the way. But it does, I can do 3 points. So I'm very specific about the angle that I'm making. Or I could just choose the 2 lines and it would pick the angle that I want. Okay. Very cool. My settings are still up. If I don't like them, I'll just click the close icon and we'll get rid of those. And you can roll your mouse forward, your cursor forward, and that will move it. If you click on the move icon and you kind of click and drag, but not on an object, you are actually, think of it like a big piece of paper. You're just moving the piece of paper across your screen, okay? But if I click on an object, then I'm not able to drag the object if the object was created in a particular way. I can click on O and move O because O was the center of the circle. I can click on Q and move Q because Q was on, it basically helps create the circle, right? It was guaranteed to be on the circle. And point P could be anywhere though. So I could move point P anywhere I want. Anyway, there you go. Feel free to kind of play around a little bit with the tools. That was lab 1. It didn't say save it, but you know what? I'm just going to practice saving it. So I'm going to go to my hamburger menu, top left, go down to say save online and say isosceles with circle. Okay. Let me just kind of show you what does it look like if you do share this. If I share this and I copy that link, when I open up a new tab and paste it, it takes me to that exact page, which is really cool. Now, if you're in Canvas, let me go here to, where do I want to go? Modules. I think I had a discussion board in here. Introductions, right? Everybody did their introductions and expectations. I'm going to make a new discussion board. I'm going to make one for chapter 12 right here. I'm going to show you, make a discussion board, practice with GeoGebra. Okay. I'll add the item. There it is. And let's publish it. We're good to go. So now when I'm in here, if I wanted to, I could post something. Now, what's great about GeoGebra is if I use this isosceles and I share it, I can use what's called an embed code. Click to copy the embed code. And then when you go to a discussion board, click on this little cloud embed, or you can say insert an embedded piece. I'm going to insert an embedded piece and paste that code and submit. And then wait for a second. And there it is. And I'm going to post reply. So this is now embedded. My entire triangle is sitting right there. And anyone who wants to can play around with it and say, oh, I see what you did here. What do you notice? So when you, as a teacher, begin doing things like this, you could create, oh, that's the angle, yep. You could create these and have this ready for students to move and explore. So they aren't spending their time creating necessarily. They're over here kind of playing around and seeing what's going on. Okay. And I'm going to adjust this because the width of this isn't really critical. And there you go. So very cool. So I'm going to leave that one open, and that's it. Now here comes the fun. What if someone else comes in there? Are they going to see that someone had screwed around with it? Watch. I will refresh and reload this site. And guess what it comes back to? It comes back to the very first thing that I had put together, which is, in this case, the triangle being off screen. That's not great. Let me go back over here and see if I can't shrink it down and maybe move this over just a little bit more. And then go up here and save online and save it. And then I'll embed the new image. There we go. All right. Let's try this. And again, if you have the embed code, you can click the cloud and paste the embed code, or you can go to insert and then embed. And I'll post my reply. So see, this is the new one, right? And now the triangle's right there on screen. So someone could like pull this around, move this, and be like, oh, okay, I see, and I can adjust those points. Right? Very cool. So let's go back to the handout, and it says next one is constructing quadrilaterals. We are going to construct a parallelogram. So in order to create a parallelogram, we're going to take points. We're going to create, and it says use the segment tool between 2 points to construct AB. That's fine. Honestly, I'm going to show you, use the segment tool to build AB and AC. And then we're going to construct 2 parallel lines, and then we will have to create kind of this point over here where they intersect. Okay. And they say intersect 2 objects tool and then click the 2 lines. You can do that. You can also click on the point tool and click right where the intersection is, and it knows that that's what you want. Things are a little bit more intuitive now. Let's see what that looks like. So I'm going to go over here and I'm going to say, okay, let's clear all. And again, my recommendation, start with a segment and go AB, and then click on point A, and you see how it starts the segment, and then just come up somewhere over here and say there's C. Now go down to your construct menu on the left-hand side, find the one that talks about parallel lines, click it, and it'll tell you down here at the bottom, it says select a parallel line and the point. So click on the point. I want to line this parallel to AB. Click on the line and then click on the point. I haven't clicked on anything yet, so it's kind of floating. But once I click on point C, it locks it. And because I'm still highlighting the parallel line tool, I could click the other line and click on B, and that locks it as well. Okay. Now up at the top, I'm going to click on the point tool, and I'm going to click point right where those intersect. Now here's the issue. If I try to hide objects because these lines are too big, if I remove the lines, what do you think is going to happen? The lines are gone, but also the segments that I wanted are gone. That's because I never created an actual segment. So now use the segment tool and you can create it like this. Excuse me. One other thing to note, I hope you can see a little bit here. The colors A, B, and C are blue, but D is not. So D, if you notice, if I click on D, I can't move it around. D was from a construction. So it was based on these lines that we made. So as I click on B and move B around, point D will move, but I can never move D independently. So this is kind of a cool way of letting you know which ones you can actually touch and move. I can move C, I can move A, but I can't move D independently. All right. Let's go back and take a look. What does it say now? Blah, 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 blah. Now it says construct a square. Okay, we're going to construct a square. And what we're going to do is we're going to build a line segment, and then, as they're saying here, build some perpendicular lines. But we need the lengths to be the same, and that's where our compass or circle tool will come into play. So they have, oh my sweet good gravy in heaven. That's a lot. They have through K. Let's just go try this one, shall we? First off, I'm going to go ahead and save this, save online. I'm going to call this a parallelogram, and then come up here and clear all. All right, we want to build a square. It doesn't have to be necessarily that complicated. However, some things are important. We need a segment. Then we need a line that is perpendicular. So I'm going to choose perpendicular line, and it says select the perpendicular line and the point. Boom. All right. So I'm feeling pretty good about this right now. So I got this ready to go. Now, take a look, though. I need this length, AB, to kind of go up this side. If we were doing it on paper, you'd adjust your compass and put your pokey part at A and turn. That's what we're going to do. Okay. So watch this. We're going to take circle with center. And if you want, you could also choose the one that says compass. Okay. Compass is fine. So we'll do compass. I'm going to click 2 points for a radius. So this is the length that I just adapted. And then where do you want it to be open? So if you think about it, what I just did is I used my compass and I kind of adjusted the width. And right now I have that width in my compass wherever I want it to go. I want that to go to point A. So I put my pokey part at A and I turn, and that will create this point up here, right? And then keep the compass tool locked. Keep that same length, and now put one at B. Okay, there we go. Why is this important? We need a square. AB has just been created. If you scroll up and put a point where this perpendicular line went up, AB and AC have to be the same. Okay. And now I could make another perpendicular line here that goes through B and find where that is, and that would be the end of it. That'd be the square. Perfect. What you can also do is build a perpendicular through C. It's going to come over, touch exactly once, and that will build it. So you have some options here on what you want to do. And the other option that you may choose to do is to build a parallel line. So I pick my line, I pick my point, and then I come over here and I construct that other point. Lastly, put in the segments. Don't forget to put in the segments. The segments are needed. And then you can show hide, and you can hide all of the circles and the other lines. And let's see what it looks like. And there is a square. Notice if I move A or B, I will get, cancel. Whoa, come back. I will get to be able to move the square. There we go. Oops. See, it looks like it's adjusting. I don't want it to adjust. I can make it bigger or smaller. Oh, I think I'm getting that from the parallel line piece. Maybe. In any case, there it is. There's my square. What do they want me to do with it? Just how to create a square. Why is ABCD a square? Okay, well, I built a parallel line. And I also built 2 lines that were perpendicular. So I have perpendicular, so 90 degrees, and all sides were exactly the same. Let me go back to the start and kind of say, hey, let's clear everything. Don't save this one. And let's go back and build it again. I can build AB. I can once again build a perpendicular line right here. And I'll build another perpendicular line right here. So now I know these are 90s. I'll take my circle with a center, and I'll just drag my circle over, and I'll drag my circle over, right? And so then I have this point right at the top, which I will label. See? And then I will do a, what do I want to do? I guess I can choose. I could actually do a circle with center radius right here and say, boom, comes down. And where that one intersects the other circle is the point that I want. Right there. And then I can hide everything. Let's get rid of the lines. Oh, select objects. And you can actually click and select them one at a time. Select all of those and then hide. And then I can just build my segments. And there is a square. Okay. Let me save this one. Save online. Square. And then we've got the measuring tools. We're going to use the measuring tools to investigate properties of two triangles. Okay. And that's fine. Use the segment between 2 points to construct triangles exactly as shown. To do this, we want to view the grid. If you want to view the grid, there's nothing wrong with that. Clear all, come to your settings menu and just say show the grid. And you can say major grid lines, and there it is. So now when you put a point on, you can pick points that are at those exact pieces on a grid, if that makes sense. Okay. All right, and it says build these shapes. So AC, AB. So if you look on the grid, build C, then go left one, up one, there's A. So A, down one, left one, got it. Up one, right three. Okay. So I'm going to drag this point to here. C was here, and B was up one, right three. There we go. And then I will build the segments. Okay. And then over here, down to right two, up to 1, 2, 3, 4, 5, 6. Okay, so I've got D, E, F. Okay. So once again, I'm going to put a point down. There we go. D, E is somewhere up over here, and F was something like this. Let's hear up to 1, 2, 3. Oh, I went too far. Okay, so 1 right back to there. And you'll notice if I'm using the grid, it'll kind of snap to the grid, so I don't have to redo everything. Oh, shoot, I just missed that. And when it does give me a different point. Okay, there we go. Let's see here. Use the polygon tool and click. Now select the angle tool and click the interior of this. Okay, click the polygon tool and click DEF in order. To measure angle A, select the angle tool and click CAB in that order. Well, that's fine. You can do that. I guess is a little bit older, but on the angle one, you can select 3 points. So if you want to measure angle A, you can click the side and the side. It'll measure it for you. And I do recommend that from time to time you grab and kind of pull it out so you can make sure you can see it clearly. Inside is a little bit challenging. Okay. It said use the polygon tool to select D, then E, then F, and then you got to go back to D. So again, it's a simple closed curve. So you got to go back to D. Now select the angle tool and click the interior of polygon DEF. Okay, so I'm going to click the angle tool and click the interior of DEF. And what you'll notice is that it did all of the angles at once. So again, I can drag them outside here so I can see them maybe a little bit better. And it did all of the angles at once. If I have created a polygon, polygon is a special type of tool. If you just build the segments, I know it looks like a polygon, but it, in the computer's mind, is just a collection of a bunch of pieces. Okay, to measure sides, we'll click on the distance tool, display the length of AB. So go back over here and you go down to the measure menu and choose the one that says distance or length, and then click on AB and it gives it to you. Choose the move tool and you can move it out to the side. Now watch this. If I choose the measure and I click 2 points, A, B, notice it does almost, well, it gives me the same measurement value, but it gives it to me as an AB equals instead of just the 3.2. Okay. You decide what works best for you. Some of you might like the AB, so you remember exactly which one it is. Others might find it to be a little bit much. I'll leave that up to you. Now display the lengths of the other two sides and the side lengths of DEF. What do you observe about the relationship of side lengths? Okay, so then it says do the rest. So as I measure, go down to my measure menu, distance or length. Again, if I click 2 points, it gives it to me this way. I can click 2 points again because I'm still in the measure menu. And I can repeat the process over here with 2 points, 2 points, and 2 points. All right. You can kind of move those out if you want. So a little bit of rounding on a couple of these. I think these are tiny, tiny, tiny bit off in terms of rounding. I happen to know kind of how the math works there. That's the square root of 2. This is 2 square root of 2, or the square root of 8. So 2 plus 8 should be the square root of 10. And we're just getting a little bit off with the rounding on these as we go. So very similar over here. But notice the CA, how does it compare to DF? Right? All right. Let's see here. Measuring areas, use the polygon tool, construct ABC, and use the area tool to find the area of this and the area of DEF. Okay, so again, if I click, I'm only going to show one. Click on this, and then go down to measure where it says area, and it says click on the polygon. So I click on this, and it'll actually say area of DEF equals 8. Let me jump back over and create a polygon here that is A to B to C, and click back to the start, and then go down, click area, and click the inside. The area of ABC is 2. The area of DEF is 8. So those are 4 times the size. It's 4 times the area. But each of the side links was only twice the area. And that's something we're going to explore as we get into chapter 13. But this tool will allow you to work with it. Let's see here. GeoGebra automatically names things to objects. By default, the names this are assigned to the first 3 objects. To calculate the sum of the triangle, type S equals this. And let's see here. It seems the area of DEF is 4 times the area. Notice the name is Poly1 and Poly2. The first 2 triangles constructed. Display the I think this is the old one. Let's see here. So right over here in algebra, there are segments drawn and there are angles created. So it looks like text name DE. So we have DE equals, and we can see that up here, and we see the distance EF is 5.7, right? So basically, when I clicked on that algebra piece, it gives me what's kind of like a calculator built in so that we can actually do math with these. And we'll take a look at that. Probably not right now. We'll do that in chapter 13. But for right now, it's fine to where you are. GeoGebra Lab 4, congruent or not. Open GeoGebra, sketch a new triangle, construct one that's congruent. Use the compass tool, intersect 2 objects, side angle side. Oh, asking you to go through the side angle side, side angle, and then a few with drawing and bisecting chords. I'll probably let you try a couple of these pieces. Yeah, I'm not going to go too far. Circumscribing rectangles. Okay, that's fantastic. Oh, the side splitter theorem. That's a cool one. So draw this triangle and then create the parallel lines, and you can create ratios, and the ratios are going to be the same. They're going to be proportionate. And then this one is the midpoint. This is a quadrilateral with the midpoints, and then you connect the midpoints. And you have to kind of try to make the inside shape be, or the outside shape be, a rectangle, a square, a rhombus, or a kite, and you get to see what happens to the inside piece. So it's basically, and these are kind of linked to the homework that was in chapter 12. And when we get to lab 9, we're not going to worry about lab 9. This is the area of polygons. We will do more with that later. We'll do more with the area. I'm not going to worry about that. And we're not going to do graph sliders and text. So don't worry about that one either. So for number 10. There will be a way to construct custom tools. I'm not so sure if we're going to use that right now. We'll probably use that in chapter 14. So I will show you how to do that in chapter 14 when we need it. Because for right now, we won't need it. And the same for for lab 12, slides, flips, and turns. That's reflections, rotations, and translations. We will be doing those in chapter 14. And so we'll be able to use this software to do that later. All right, and right on Pythagoras, this will be chapter 13. So when you get down to the assessment, let me go look and see, what did I do for the assessment here? 1, 7 to 8, 11, and 13. So not a ton. I didn't do a lot. 1, inscribe a circle in a triangle. Okay, that's something we need to know how to do. That's the angle bisector. So 1 is a good one, right? Then I said do 7 and 8, inscribe a circle inside of a square. Okay. And then find the percentage of area in the square not covered by the circular region. So we may need to find the area of the square and the area of the circle. And then inscribe a circle in a square. Find the percentage of the area of the circle not covered by this. Okay. Use the answers to determine whether a square peg might fit better in a round hole. All right, that's up to you. 7 is there. Question 8, draw a rectangle with 2 circles as shown. And find the percentage of the area not covered by circular regions. There we go. And repeat the process using 4 circles. That's 7 and 8. And then we have 11 and 13. So here, 11 is construct any triangle and its centroid. That's the intersection of the median. So use the midpoint tool. And then measure the areas of these triangles and drag a vertex and observe the relationship between the 3 triangles. So this one is kind of, well, one of my favorites. So I'd like you to try it. Again, I'm not assigning a ton of homework out of this section, right? There's what, 5 questions? 1, 2, 3, 4, 5 questions total, no MCs. Yeah. And then question 13, construct ABC and its centroid, its orthocenter, and its circumcenter. Construct a line through O and G, drag one of the vertices, and what do you observe? And then calculate this ratio, OG to HG, and see what you think about that ratio. Does that ratio stay the same? Does it change? What happens? So this is, that's all that I'm asking you to be able to do right now. All of these, though, anytime you have homework questions, when you are doing homework questions, you can come in here and create whatever it is that you're looking for. So if you wanted to build a perfect, right, a perfect a perfect equilateral triangle, let's start with that one, right? Perfect equilateral, you could start here and say, okay, I'm going to put my compass right here. I'm going to put my compass right here. And I'm going to find where those intersect right up here. And then I'm just going to create these segments because I know all 3 of the segments are exactly the same. And that means all of the angles will have to be the same. So you just built a perfect equilateral triangle, right? Well, what's great is you also could have had a triangle right down here, which is where we kind of create things like the rhombus. And then we construct that intersection from C to D, and we have a perpendicular bisector. So all of these things can be done pretty quickly. If you need things quicker, then the construct sub-menu will most likely be the place to go. For example, perpendicular bisector, select 2 points or 1 segment. Watch this. If I just click the segment AB, it builds the perpendicular bisector, which means that all of these things that I did before, right, all these things that I had drawn, I didn't actually need. I just need AB. And I click perpendicular bisector and it does it for me. I want you as students to understand, where does it come from? It comes from the idea of the rhombus. And if I ask you to prove why is this going to give me the perpendicular bisector, you should be able to say, I create congruent triangles. These angles are congruent and supplementary, so they're 90 degrees, and the A to M and whatever point they're going to tell me, what is this, E? A to E and E to B is going to be congruent because of the CPCTC. So yeah, that takes care of it homework-wise. Again, not a ton of pieces here. And just remember, I'm not asking us to do everything in this guide. We're only doing a few, but my goal was that you get familiar with the tool. Whoa, it got dark outside. Sorry about that. And my light doesn't work. I wonder if this light works. Oh, it's like I'm a YouTube star. That is freaky. Okay, forget. Pretend you never saw that. All right. So that's it. That's it. Practice. Try it. Get yourself a GeoGebra account. We're going to do some of this in class when we come. And if you have questions about it, let me know. All right. Off you go.